Newton's three laws of motion make it clear that forces play a central role in determining the motion of an object. In the course of study, you will encounter many different kinds of forces, including the gravitational force, normal or contact forces, and forces due to tensions and springs. Later you will come across electric and magnetic forces. It is important to keep in mind that, when applying Newton's laws, the sources of the forces do not matter. In many problems, multiple kinds of forces act on the same object, for example, gravitational and electromagnetic. It will often be the case that you will have to determine these different types of forces and then apply Newton's laws. Although we've identified numerous kinds of forces, they are all derived from three fundamental forces, the only three that we know of so far. These three are the gravitational force, the strong nuclear force, and the electroweak force. The gravitational force is the attractive force between masses. It is responsible for the force of weight and for the orbital motions of satellites and planets. The strong nuclear force is responsible for the attraction and binding of nucleons, protons and neutrons, in the nucleus. The electroweak force is responsible for some radioactive decays involving beta particles and neutrinos, but is also the origin of the likely more familiar electromagnetic forces, such as the electrostatic forces between charges. The electroweak force used to be separated into two what they thought were fundamental forces, the weak nuclear force and the electromagnetic force. However, these two forces were unified into a single electroweak force by Glashow, Salam, and Weinberg, who won the Nobel Prize for their efforts in 1979. The important concepts of this section are the following. First, Newton's laws of motion apply to an object regardless of the types of forces acting on it. And two, there are three fundamental forces in nature: the gravitational force, the strong nuclear force, and the electroweak force.